I know you guys are really busy, so thanks for taking time out to plan for next year. So we want to think about the deep, enduring understandings in the data and statistics course that permeate the subject, that are core to the discipline, that will keep coming around, and that if kids don't understand deeply, then they didn't understand data and statistics. So not just topics.
Interpretation.
So, like, instead of saying we want them to understand gene mutation, what do we want them to understand about gene mutation? That it's a random process where variation enters a population. So,
Statistics is a way to represent data, or
okay. So statistics
is a various
is a way to
represent.
and summarize data.
Yeah.
Represent, summarize.
Display.
And then data can be represented graphically or visually. There's different ways to display those statistics.
Graphically, visually. I mean, orally, like, do we want to say like in English as well? Like the kind of core concept we have of like words, charts, equations, and graphs. I'll get back to that. Data can be represented in all four ways.
Oh, we have it.
One that I think is kind of powerful for kids is that the difference between statistics and probability. That statistics is when you know everything about a sample and you're making guesses about a population. And in probability, you know everything about the population and you're making inferences about the sample.
What is a sample?
Yeah, so what is a sample? What do we want them to know what a sample is?
Collection of data used to calculate statistics, or used to.
How about a subset? Like a subset of a larger,
subset
Larger
Is
population.
it a subset of a
larger population?
Do we want to do something more than that? That's used to infer larger trends among the total population? Or trends, just trends among the...
Which is about the population. Okay, so sampling is taking a subset of a larger population. Okay.
I mean, these are I think the big three things about statistics.
Okay.
What is statistics? What is a sample? Then
What do you
how
use
do
it
we, how do we display that, or how do we?
Okay.
When and why do you use a sample?
Yeah, actually, that's a great one too, right? Why do you use a sample to save
what makes
time
a
and
good
money?
sample?
Yeah,
Save
what makes a good
time,
sample?
you
Yeah.
can, it just, you can send out 1 million surveys.
But are these points under this?
Okay. Yeah,
And
that's true. That's true.
What makes a good sample? What
Well, the larger the sample, the more accurate. Does the size of a sample,
Okay, a good sample is representative of the population. Can't write that fast.
something
And
like that.
the size, the larger the sample, the more accurate the statistic. Statistic is accurate for the sample, not necessarily for the population. Okay, cool. So that's a lot for statistics, and those are the big things that we'll frame the course around. And then the second part would be the probability. So a good definition of probability.
is the likelihood of an outcome?
Of an outcome
Of a
given the
certain
number of
outcome.
outcomes.
Yeah, I mean, the formula is a deep understanding, right? The number of favorable
An
outcomes
outcome-
over number of total
The
outcomes.
likelihood an outcome, the likelihood something occurs given the number of chances.
And
And-
it's a ratio. I think that,
Well-
that the fact that it's a proportion is kind of an important, deep understanding that it's not just this random,
You should
it's not a
al-
number.
They should also know
And
that
that you can express it as a percentage, as a
Yeah.
ratio, as a fraction.
And it's always a number less than 1. So it's always a number less than 1 described as a ratio, percent, or decimal. A 0 probability is impossible, and a 1 is certain. Okay. How about what you were saying, the difference between empirical and theoretical probability? Is that
yeah,
something?
I
And
mean,
then we want to get conditional.
it's just important to know, like, give them examples. When experimental probabilities, after conducting an experiment, whether it's science, whether it could use die or it could use deck of cards. It's the whole point is theoretical comes from something that's given. You only have a coin. It's a head or a tail. It's 1/2. That's theoretical
So-
probability. There's no experimental there. That's how you understand.
So theoretical probability is based on the knowledge of the population, and empirical probability is based on or calculated from an experiment. The more accurate, the greater your sample size, the more accurate the empirical probability
And
is.
again, we refer back to almost statistics.
Where's my second? Oh, this is my second. Yeah, exactly. This goes back to my point that statistics, you know something about the sample, you make inferences about the population. And then probability, you know something about the population, you make inferences about the sample.
The probability is determined by the conditions. You know, that's just the understanding, I think, and if you can cover that in a week or 2 weeks, then I think you've done your job. I don't think it needs to be,
Hey, none of these enduring understandings can be covered that quickly. Probability changes, would you say probability changes based on initial
the
conditions?
probability is determined or changes based on the conditions.
Okay,
Yeah.
And the reality is they are going to be taking the regents
the algebra regions.
this
yeah.
year. So,
Yeah, that's true, we should think skills as well. Like are the skills that we want them to know embedded and intertwined with these understandings, like creating histograms, measures of central tendency and when mean is better than mean or something like that. Maybe we have there.
single compound probability.
What do you guys think about counting? Is that something important? What do you think about counting?
Well, I think it's important enough that we should.
Oh, lineups.
Why?
What about ways to finish in a race, like the Olympics? How many different ways can these guys finish first, second, third?
There's
it ties in
10,000 things that you could calculate with
Yeah.
permutations and combinations. There are millions. I mean, they did a whole project on it.
So
But when
do
do you
it.
when do you really care about it?
Then why was it taught when I was a kid? I mean,
I don't know. Why are we teaching just things to teach them? Yeah. For whom is counting relevant?
there's plenty of classes I probably took in college that it's just so we have a taste of it. I'm not going to use it. I'm not using psychology right now. I had to take it,
I'm
but
using it on you though.
but what I'm saying is that's the point though. Certain people it's relative at certain points in time. I mean, you want to give the kid exposure. Then why do we have to give our kids pre-calculus? They're never gonna calculate the area
I
inside a
disagree.
spiral macaroni.
That's true, but that's not what we do. But they are going to get credit cards, and they are going to need to know that the difference between a 1.6% APR and a 7% APR is enormous in the long run.
Yeah.
That is something.
What if
they
this
need
kid
to know.
never? What if this kid's? What
But
if
they're
this
not going to be like, I have the choice of 4 credit cards, 3 colors, and 4 patterns.
You
I don't know.
can't make that decision for that
I'm fully
person.
against counting. I can't think of a single relevant example in the real world that anyone, except when you and I did period codes for scheduling, and we actually knew the limitations of the computer program, and we had to figure out how many different 6-period codes would come up. It's the only time in my life I've ever thought it was remotely relevant.
Okay.
And we didn't even matter.
One
because
of
they-
our
they-
students becomes a math teacher and
You
has
found
to
an
do the
example.
programming.
You found one example. Therefore, it is relevant in somewhere, someplace. I mean, I'm not saying it has to be a whole unit. I think it could be. They could be exposed
Okay.
to it when you do
As-
probability.
yeah, okay.
It's just. I think it's something that if a kid who's curious,
Okay.
he should have a way of figuring it out. And that's just.
All right, well, there's nothing wrong with math for math's sake anyway.
I mean, it could be a 1 day to 2 day thing. It doesn't have to be. I'm not saying it's a major understanding, but I think it's something that the kids should understand. That this,
Okay, so are we done with the deep understandings? That's pretty fast if we're done with the deep understandings, which we're actually also done in 4 minutes, so it'd be nice if we were.